All right. Thanks for the introduction, Elena. Good afternoon. My name is Hyeonsu Kang. Now I'm working at MIT Scheller Teacher Education Program, where we are designing the next generation science education curriculum using a block-based programming language like Logo. Omnicode is a project with Professor Philip Go at UC San Diego, and at the core of this project are observations from programming labs at universities. Two challenges that we faced are for novice programmers are in forming correct mental models and in debugging, testing, and communicating their code to others, especially when things don't work as they expected. I imagine that these challenges may sound familiar to many of you, and in order to alleviate them, we drew inspiration from how novice programmers externalize their mental models and hypotheses using visual representations. And on the left is a picture of a student drawing and explaining what he thinks is the machine's inner working when his code is run. And this kind of a visual representation is often used in verbal communication among the students or between student pairs and teaching assistants, as shown in the right picture during the lab sessions. And there are several lines of prior research in whys and hows on the benefit of visualization in programming. And two of the most direct connection to our work include Python Tutor, with which users can see step-by-step visualization of their code execution, and Brett Victor's essay called Learnable Programming, in which he provides us practical advice on how to enable programmers to see and understand how their programs execute. Building up on this prior work, Omnicode explores a question of what if we display the entire history of runtime values for all variables all the time. Extending on this idea, Omnicode not only shows the runtime values, but also their dyadic relationships. And in addition, it provides bidirectional interactivity such that users can easily hone into interesting parts in the viz and see the relevant portions of their code. Specifically, lecture materials including test descriptions, skeleton code, test cases, and their answers are first created by an instructor and loaded into Omnicode. When students edit their code, Omnicode continuously runs it and updates the viz. This viz includes runtime values of all variables as well as their dyadic relationships. Users can also create their own custom plots using Python expressions on X or Y axis, as shown in the top right-hand side corner, or system-provided variables such as execution time or line number. And Omnicode will automatically update those plots as well. And in addition, for non-numeric type variables, like list or dictionary, Omnicode automatically adds scatterplots of their derived values, such as the length or the sum of their keys. When students select a portion of their source code, Omnicode uses this selection to filter relevant marks in the visualization through AIST analysis. Conversely, when students select marks in the viz, Omnicode filters marks in all other plots and highlights the corresponding lines of code in the editor. Students may also look at detailed memory-like visualization as shown in the tooltip by selecting a single line of their code. So to evaluate, we recruited 10 university students, each with a 75-minute session. We introduced Omnicode and demonstrated its features for the first 15 minutes, then let students solve 3 programming problems involving numerical lists in Python. And finally, we debriefed their experience with Omnicode in the last 15 minutes. If students solved all 3 problems in time, they were given an extra task of verbally explaining the behavior of their programs. 3 questions that we used in the study. One, computing the difference between the maximum and the minimum of a given list. Second, computing the difference between the mean and the median of a given list. Third, computing the average of smallest 25% values of the list. The result provided a glimpse of Omnicode's benefit in learning in 3 regards. First, students thought Omnicode is a meaningful medium for debugging and forming mental models. For example, one student examined how the value of the temp variable changes over time as shown in the quote, and interacted with visualization marks to see the corresponding lines of code and corrected his mental model through evidence-based argumentation. Students also engaged in impromptu hypothesis testing using Omnicode. For example, while implementing the bubble sort algorithm, one student spontaneously examined whether Python lists were copied by reference or by value, which was unrelated to the task. Another student was also not sure whether numeric division gave an integer, returned an integer or a float type, but he could quickly gain confirmation through the viz. Oops. That was that. And finally, students thought that Omnicode helped them explain and communicate their program behaviors more clearly. One student said, by slicing a specific I value and brushing over its change, I can see how all other values of the program change as well. And this is a great overview compared to what I used to draw on the board. Other students also mentioned the usefulness of seeing all of the runtime values as well as their dyadic relationships, as well as filtering marks in the viz and highlighting the relevant portions of the code as affordances for communication. So Omnicode really surfaces a new design space for novice-oriented small programs that can benefit from always-on runtime value visualization. Although Omnicode adopts a rather simple form of visualization, and there's certainly more space to improve the representational fidelity of it, but more importantly, how the viz and its surrounding interactivity supports evidence-based argumentation and communication is essential to learning how to code. There are challenges as well. Students repeatedly mentioned visual overload as a bottleneck for effectively finding useful information from the viz. So overcoming this visual overload and designing for interestingness and meaning making therefore requires consideration of how to support students' engagement and exploration. In sum, Omnicode is a novice-oriented, lively, interactive, and semantic program value visualization for learning. We reported its benefits in debugging, forming mental models, and explain programming behaviors to others, as well as implications for design and challenges for the future. Thank you. Yeah, that's a great question. I think there are different lines of research that people might find interesting in relation to that question. And 2 weeks ago at the LHCC, the Block and Beyond, I think, workshop, they had the kind of a block-based representation and how to use that, especially for novice programmers like kids or less professional developers. And I think the representational, kind of reiterating what I touched upon in the presentation, but the representational fidelity itself is very important, but at the same time, thinking about how that kind of fits in the context of encouraging communication and hypothesis generating and generation and meaning making is what is really important for the future of education. So